Yeah, hi everyone, Mr. Markwick here. Today I want to walk you through how to solve simple linear equations or simple algebraic equations. The process I use for this is basically using an inverse operation to isolate the variable. In this case, all the examples I've got here, the variable is x, but the process will be the same no matter what your variable is, whether it's a y, an a, a b. We've spoken about what a variable is, and hopefully that's not new to you. Now, before I jump into these examples, I perhaps will start with something a little bit easier. So let's come up with an equation. Let's do x plus 4 equals 6. Okay, it's a pretty straightforward equation, and you've probably worked out the answer is x equals 2. Okay, because you know that if a number plus 4 equals 6, then that number must be 2. And how did you get that? The difference between 4 and 6 is if you're adding 2. Okay, that's kind of what we're doing in all these examples here. We're using the inverse operation though. So the difference between 4 and 6, the difference means subtraction. So what you're actually doing is you're doing 6 take 4 in your head automatically. Okay, so that gives you an answer of x equals 2. Kind of going to do that in today's examples, but it might be a little bit more in depth. So the first example you can see here, which is 10a, involves 2 steps rather than just one like this example I've given you here. So the equation is 2x plus 3 equals 4. Okay, I'm looking over here. Now, in this equation, there are 2 terms on the left-hand side, 2x and positive 3, and I'm going to remove the part of that equation on the left-hand side that is furthest removed from the x. Now, the 2 terms on the left-hand side, 2x and positive 3, 2 is the coefficient of x, so that's going to stay for now. I'm going to get rid of that positive 3. To get rid of the positive 3, I'm going to subtract 3 from the left-hand side. If I do that on the left-hand side, this is what I'm talking about, balancing, I need to do the same on the right-hand side to keep this equation balanced. So now I can go ahead and do positive 3 take 3. That actually cancels itself out. I'm left with on the left-hand side 2x, which is equal to 4 take 3, 1. Okay, so 2x equals 1. Well, 2 times by a number is equal to 1. What is that number? What is the value of x? Well, to get rid of the 2, the operation happening between the 2 and the x is multiply. So I need to do the opposite of multiply, which is divide. Algebraically, I'm going to write that as a fraction. If I divide on the left-hand side, I'm going to divide on the right-hand side. So, times 2 divided by 2, you're gone, mate. I'm left with x equals 1 divided by 2, which you can write as decimal, but in algebra, we tend to leave that as a fraction. So x is a half, or 1 over 2. Okay? Now, it might not be a fantastic example to start off with. I've given you a fraction rather than a whole number. That could have been a little bit cheeky, but, you know, if you follow the process, sometimes your answer will not be a whole number. Okay? Sometimes they're not even nice, clean fractions like that, 1 over 2. Let's look at this second example here, which is example 10b. The expression is x over 4, x divided by 4, take 3 equals 7. Again, I've got 2 terms on the left-hand side of the equation, and the term that's furthest removed from the value x is the positive 3. So what I'm going to get rid of first is that, negative 3, and what I'm going to get rid of is that negative 3 by, let's one step ahead, adding 3. If I add 3 on the left-hand side, I also need to add 3 on the right-hand side. So minus 3 plus 3, that's cancelled out. I'm left with x over 4, x divided by 4 equals 10. Okay, now to get rid of the 4, the operation happening between the x and the 4 here is divide. So the opposite of divide by is times by. So divide by 4 times by 4. That gets rid of it. If I do that to the left-hand side, I need to do that to the right-hand side. So I need a times 4 over here as well to keep it balanced. So x is equal to 10 times 4, which is 40. Okay, guys, so that's a nice whole number answer. And again, I'm keeping the equation balanced. Whatever I do the left, I do the right. Okay, you can see those in these examples that I've done. The third example I'm going to go through here is 10c, and this time the expression is 5 take 2x equals 12. This time the term involving the variable x is in the second term. It's not the first term on the left hand side of the bracket, but things don't change. Okay, the term that's furthest removed here is the 5, so I need to remove that first. Alright, the opposite of, or to get rid of that 5, because it's in fact a positive 5, is I need to subtract 5. So I need to take 5 from this side. If I do that to the left hand side, I need to do it to the right hand side too. Okay, positive 5, take 5, it's cancelled out. I'm left with on the left hand side minus 2x equals 7. Okay, now this is important because this is where a lot of people make mistake. They see the minus 2 here and automatically they want to add 2 to get rid of it. Now that's not what's happening between the coefficient and x. Minus 2 is the coefficient. It's minus 2 times by x. So to get rid of the minus 2, we need to do the opposite of multiply, which is divide. And I'm going to divide by minus 2. Get rid of that minus 2 altogether. Okay. What I've done though is I've brought it across here and I need to divide by minus 2 here too. So I'm left with now on the left hand side just x is equal to 7 divided by minus 2. Again, that doesn't go, so I'm going to leave it as a fraction, 7 over 2, and that's a positive divided by a minus, so it is a minus fraction, minus 7 over 2. Okay, that's the solution to 10c. Right, give myself some room, and I'm going to write the example 10d here, which is 2x over 3 plus 5 equals 7. And I may as well write example E as well, which is a little bit longer. 2x plus 4 over 9 is equal to 2. Right, let's start with example D and how we go about solving that. Now, again, there's only two terms on the left-hand side, so 2x divided by 3 and positive 5. The positive 5 is furthest removed, so I'm going to get rid of that first. To get rid of plus 5, I take 5. Again, we do that on both sides. I'm left with 2x over 3, which is just one term, is equal to 7 take 5, which is 2. Okay? Now, what's furthest removed from the x here? What do I bring across first? Do I bring across, or what do I get rid of rather? Is it the 2 or the 3? I'm going to get rid of the 3 first because it's furthest removed from the x. Okay? I'm going to do the opposite, divide by 3. I'm going to times by 3. If I times by 3 on the left hand side, I need to times by 3 on the right hand side. So, 3, divide by 3 times by 3, cancelled out. I'm left with 2x equals 2 times 3, which is 6. Okay, then you get rid of the 2. Again, the operation happening between the 2 and the x is multiply. Opposite of multiply is to divide. I do that on both sides. I'm left with x equals 6 divided by 2, which is 3. Okay, now you can see that our examples are getting a little bit more complicated in terms of the number of steps. The process still stays the same. Right, final example here, we have 2x plus 4 all over 9 equals 2. Now again, I'm going to remove the number that's furthest removed from x. And in fact, it's actually, if I'm looking at this term on the left-hand side, it's actually the 9 that needs to get rid of, we need to get rid of first. So because the 2x, there's actually two terms, it's the 2x and the positive 4, they're both divided by 9. So to get rid of that, I'm going to multiply by 9. If I do that over there, I'm going to multiply by 9 over here, which cancels it out on the left-hand side and gives me 2x plus 4 is equal to 2 times 9, which is 18. Okay, next step. You guessed it, get rid of that 4, subtract 4 from both sides. I'm left with 2x equals 14. And to get rid of the 2, again the operation happening between the 2 and the x is multiply. Opposite of multiply is to divide. Divide by 2 on both sides. X equals 7 divided by 2, 14 divided by 2, which is 7. Okay, so guys, hopefully that helps. If you're in my class and you're watching this video, today the questions on DayMap are very specific in terms of next to them. It won't just be an example 10. It will say example 10A will help you with that question. So go to this example and use that as a blueprint. If it's got example 10B, go to this example and use that as a blueprint. And so on for the rest of them. Okay? Hopefully that helps, guys. Please have a go. If you're not sure, have this video, pause it when you need to. Like I said, try and use it as a blueprint. If you get stuck anywhere, send me a DayMap message. I'll endeavour to try and get back to you as soon as I can. But yeah, really have a go. One thing to watch out for is those negative numbers like we saw in example C. Just make sure, okay, to get rid of that value on the left-hand side, you're doing the opposite operation, okay, with what's happening with the variable. Hopefully that makes sense, but if it doesn't, like I said, get in contact with me and I'll try and help you out where I can. Thanks, guys.